this position. So this is theta. And now look at this, the wedge will be somewhere here. So this will be the displacement of the wedge. Let me take x2, and this is the ground. This is what happens here. Of course, the block and wedge will have velocity. I'm not interested. Time being, let me just only get the displacements. So the displacement of wedge is needed, that one. So if you take this is the origin, what is the net force on system along x-axis? 0. So therefore, there won't be change in position of center of mass. So xcmi equal to xcmf. I'm showing in detail. Next, everything I'll do by formula wise. Huh? So from origin, you calculate at what distance the block m1 is. M1, the length AB is L, no? So what is the horizontal distance? L cos theta. L cos theta. M2, let it be at a distance R. What is R? R is the center of mass of the wedge. So let it be at a distance R, that one, by M1 plus M2. Finally, at what distance the block is? At a distance x2. And at what distance the wedge will be? R plus x2. So at what distance the dot will be? No, at a distance of R plus x2 all divided by M1 plus M2. M2R get cancels. So we want only x2. So what is x2 equal to? M1L cos theta by M1 plus M2. This is what the displacement of wedge. Here first case what we took, all surfaces are smooth. If you want displacement of block, you can calculate L cos theta minus x2. The displacement of block will be towards left here. In the diagram, I'm showing the displacement, so therefore I'm not going for any negative signs. And now, how to do by formula? Later part in the numericals we can see like this. If you are unable to think using logically formula, take help of diagram. For that you have to choose origin. So if I change origin, answer will change. No, we know that location of center of mass is independent of the choice of origin. No? So look at the where the center of mass of system will be. Center of mass of system is somewhere earlier here. No, now it will be there only. It has not got displaced along x-axis. No change in position of center of mass. You can see here. Block change in position, the wedge changes its position, but the center of mass of system didn't get displaced here. Can you say anything about delta xcm? Delta xm is 0. What about delta ycm? Please look at carefully. It got displaced. No, earlier the center of mass is here. Now where the center of mass is, it got descended. Look at the height from the ground. So delta ycm is 0 or non-zero? It's non-zero. And any reason for that? Because net force acting on system along y-axis is non-zero. Sir, how do you can say that? Look at the M2G. What are the net force, resultant force acting along y-axis? The weight of the block M1G, weight of the wedge M2G, and N2. Sir, why can't you write N2 equal to M1 plus M2G? That later on in the numerical will show that N2 is not equal to just M1 plus M2G. There is a resultant force acting on the system. That's why the center of mass is undergoing displacement along y-axis or is accelerating along y-axis here. The diagram itself shows, look at this spot now. The center of mass of system is here. Now it descends. But there's no displacement along x-axis. Okay, this is about when both are smooth. I'll make the inclined plane rough and the ground let it be smooth. And any change in the answer? Second situation, mu1 non-zero, mu2 0. I'll write fresh here. Second situation, mu1 non-zero, mu2 0. Now, what are the forces that will be acting on the wedge block system? You have to go back to again laws of motion, nothing big, no, there's nothing new we are going to learn here. There'll be friction acting between the block and the wedge. Other forces, normal contact, N1, here N1, the weight M2G, and this is N2. This is theta. Again, check net force acting on system along x-axis, zero or non-zero. F1 cos theta, F1 cos theta, N1 sin theta, N1 sin theta. Resolve this force. F1 cos theta, F1 cos theta, N1 sin theta, N1 sin. Net force acting on system along x-axis. In fact, it is non-zero. Delta XCM, non-zero. What is the displacement of wedge? Now also the same formula. But sir, there is a friction, nothing to do. Of course, the speed will change, but the displacement will be as it is. What about net force on system along y-axis? Non-zero. Center of mass will shift. Okay, whether the inclined plane rough or smooth, as the net displacement of the wedge will be same. No change from the previous problem. Okay, no, so you have to take the situations, problems of these kind of rough, smooth, every numerical open. Smooth is there, make it rough. If it is rough, make it smooth, then analyze it. And now if both are rough, or select a mu1 0, mu2 non-zero. No. What do you mean by mu2 rough? So this surface is rough. So what are the forces that will be acting on the system? Normal contact N1, N1 you show it. There's no friction, so here the inclined plane is smooth, no? This is mu1. Let's take this one. So M2G. Normal contact N2. In what action the friction should act on the wedge? Towards left. Because N1 sin theta will try to shift the wedge towards left, so the friction will be acting in this direction. Whether the wedge is at rest or in motion, the net force, what is the net horizontal force acting on system? F2, no, this is unbalanced. N1 sin theta, N1 sin theta. This N1 sin theta acting on the wedge will be balanced by N1 sin theta acting on the block. So that N1 will become internal to wedge block system, whereas F2 will become external to wedge block system. So net force is acting towards left. So center of mass will shift towards left here. What about the other thing along y-axis? And anyway, along y-axis in all the cases, net force along y-axis will be non-zero. So here what will happen? We'll get non-zero, delta xm non-zero. No longer, you cannot use this formula. You cannot use this formula to calculate displacement of wedge. Then how to do that? Calculate acceleration of the wedge. Then what is the time taken by the block to move from A to B? In that time, how much the wedge has moved. They may trouble you with questions of these kind also. Okay. And then along y-axis, non-zero,